Quantitative Data Analysis Techniques, Assignment 4.51, Theory, Ashley Adamson-Edwards. Firstly, it's important to acknowledge that a quantitative research project allows for a much broader study to take place than what a qualitative research project would. In addition to this, it also allows for a lot more accurate data to be produced rather than an array of data. The conclusions can be drawn from. To start, the quantitative data analysis project or research comes first is data preparation. Data preparation acts as the initial stage into the analysis of quantitative data analysis, therefore establishing a foundation for the later stages to come. This acts as a critical stage into the process of analysis quantitative data. However, in order to allow for efficiency and less time spent on later stages of your analysis, the researchers often use a series of methods and techniques. This is so that the quantitative data that have been collected from a study can be managed into an organised fashion. These methods are range, rank order distribution, simple frequency distribution, and grouped frequency distribution, which all possess a variation of characteristics that aim to contribute to a research study. Firstly, we have the range. The range represents a method of organising data that establishes the span from one end of the data collected to the other, due to the fact that that this is used within a quantitative data. Much like all these methods, it is indicated for a numerical value, which states according to Patia 2019, the highest and lowest value in a set of values. Therefore, providing a distance which can be used to suggest the degree of variation or difference in a study in order to find the range of set of numerical data, the value which represents the lowest piece of data collected for a particular quantitative data collection method must be deducted from the highest. For example, during a quantitative study regarding British gymnasts' sit-and-reach test score, a researcher may want to understand how big of a difference there is in British gymnasts and ordinary people's sit-and-reach score for flexibility. Therefore, as shown in Figure 1, the researcher would subtract the lowest value of 22 from the highest of 56 to establish a figure of 34. This new value of 34 will represent the range in sit-and-reach test scores for the British gymnasts and could then be compared with the range within a sample of ordinary people. As a result, the method of range has been used to organise a researcher's data in such a way that they can now gain an understanding of the degree of variation in a particular set of results. In addition, later down the line, in terms of carrying out the analysis of your quantitative data, the method of range will also benefit the researcher to a further extent. This is because the data will be organised into a simpler way, and therefore a researcher will be able to refer back to it at later stages, consequently allowing the process of analysing to be efficient and take a lot less time. In addition to the method of organising data referred to as the range, we also have what is known as the rank order distribution. Rank order distribution consists of the researcher relating each one of their values within a table that signifies their rank in terms of which the researcher wants to rank. For example, if a particular study that needed to organise a piece of data regarding the height of British gymnasts, they may choose to use rank order distribution in order to do so. Therefore, as I have done so in Figure 2, the researcher would organise a rank order with the highest, in this case the tallest values, placed at the bottom, and the lowest, in this case the smaller values, at the bottom, consequently indicating an order of values that have been positioned based on the ranks the research has decided to create. Particularly with this example, this will allow the researcher to clearly determine and recognise what the varied ranks mean to allow for a less time-consuming analysis, which is more efficient. This example would be perfect for this particular organising method due to the fact that it aims to portray a rank or hierarchy amongst the variation of values. However, in order to add to the simplicity and clarity of this method, it is typically used with data that consists of 20 or less values. For instance, if a researcher has more than 20 values for the height of British gymnasts, then perhaps this method for organisation isn't the best suited. This is because a greater extent of values would cause the distribution to be extremely elongated and consequently causing the data to be perhaps complex. As a result, when trying to understand the specific values that have been ranked in each position, someone may struggle as the study has been portrayed to be too complicated. The method for organising quantitative data known as simple frequency distribution. This method enables an understanding of not only what occurred amongst the data, but also how many items This happened due to the fact that it covers the organisation of two topics. The way of presenting this is done through two separate columns, which however relate to each other. This is done by labeling each column to show what they represent. Because the current method of interest in simple frequency distribution, the first column will represent the raw data collected from the study and the different values that they refer to, consequently giving an indication into the values were recorded. Whereas the next column involved within this method refers to how many items the previously value occurred and therefore showing us frequency. In addition, it is widely known that the frequency distribution is commonly associated with studies that are attempting to provide a summary variable within categories. This is because the numerical values provided by the quantitative often possess an array of values that are distinct from one another. For example, if a particular researcher was researching the skinfold caliber readings regarding British gymnasts' biceps, they may choose to use this method of organisation. In this case, as seen in figure 3 on the PowerPoint slide, the values like a 5mm or 10mm have been positioned on the left column to indicate the different measures the participants' skinfold test measured. Furthermore, within the right-hand side column there are frequency digit measures, which show you how many times each of the different measurements recorded were produced by the participants. More specifically, this method of organising data is not only useful to the researcher due to its simplicity, but also because it shows which values are more common and possibly more significant to the study and which aren't. For example, within this example I've used the value of 5mm is indicated to have been recorded 4 times, which acts as the most common value within this whole project. Therefore, whereas the value of 90mm could be suggested as an anomaly to the study because it only occurred once. Therefore, this method has pointed out a key aspect of the data collected and can be successful in its ability to be efficient by indicating this clearly and the strong points it makes in little time. Finally, much like previously stated method of rank order distribution, this method is also usually used for sets of data that only consist of 20 or less values to avoid the study being organized into a too complex way. Finally, we have organisation method of frequency distribution. Frequency distribution is used for quantitative data that consists of many values that need to be together in order to provide clarity to the study. This is done by also consisting of 2 columns where in the first of the raw data is collected. However, unlike simple frequency distribution, this method involves the first column containing groups of values that would otherwise show an array of figures complicatedly spread out, whereas the second column indicates how many times the participants produced a piece of data within that specific group. But these groups of data are calculated by a simple equation that ensures that the groups are created fairly. This involves a researcher finding the range and then dividing that by 14. This will therefore produce an ideal number of groups, 14, to allow a well-organised structure to how this data is portrayed. Much like the previously mentioned methods, when a researcher refers back to this initial stage of analysis, the data will be clearly grouped together to avoid the study from providing lack of clarity to eventually easily draw conclusions from the later stages. For example, a study looking into the peak flow results of British gymnasts may have their data organised into group frequencies. Therefore, as seen in figure 4, the researcher would take the highest value of 700 and subtract the smallest value of 350 away from that. As a result, now that the range has been calculated, the researcher can then divide this number by the groups that they would like to determine. Because the ideal number of groups is 15, the researcher would divide 350 by 14 to establish each group containing 25 values each. Consequently, within this example, on the left column would be positioned the different groups that have been previously created. Whereas, to indicate that many times the participants scored within these groups of peak flow are scored in the right column would be distributed the frequency figures. Because of this, the scores in the right column will be distributed. Because of this, the method has been well suited to a specific set of data that involves a large range of values, as it has been well structured and organised. Much like all the other methods for organising data, this is now laid a foundation down for analysis at a further degree due to the fact that this data is easily accessible